let's understand the next example, that is example number 8. In this example, it is given P is a point which is equidistant from two lines L and M. Okay, ultimately it is given there are two lines L and M. So let us draw two lines. Line L, suppose this is line L and this is line M. Okay, so two lines L and M intersecting at a point A. It means the two lines L and M are two intersected lines. They are not the parallel line. No, they are intersecting each other. Okay. So at which point they are intersecting? At this point they are intersecting. And the name of the point is A. This is clear. And it is given P is another point which is equidistant from two lines L and M. So we have to take a point P anywhere. Anywhere we can take. Suppose I take a point P here. Now this P is equal distance from line M and from line L. Okay? That means the distance from P point to the line M, that means this distance is equal to the distance of point P. This is the line L from the line L. Understood? Let me tell you an example. Suppose there is a line and the name of the line is AB. Now there is a point P which lies above the line. The question is, find the distance of the line of the point P from the line AB. We have to find the distance P from this line. How we can find? Now tell me, suppose I join this and this point, 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 this point, this point, this point. Then out of all the distances, so these are the distances from P to the line, yes or no? Yes. This is the distance, this is also distance, this is also distance, this is also, and these are also distance. Then tell me, which one is the exact distance? Which one is the exact distance between the point and the line? Can we say this is the distance of the point from the line? No, it is not the distance. Can we say this is the distance of the point from the line? No, it is also not the distance. Can we say this one is the distance of the point from the line? No, this is also wrong. Then what is the exact distance? Always remind the smallest distance. The smallest distance between a point and a line is known as the actual distance. Okay, the smallest distance between a point and a line is known as the exact distance. So tell me, out of such distances, which seems to be the smallest distance? This one. This one seems to be the smallest distance. Okay, so this is the exact distance and another not the exact distance. Understood? Here, one more example. Let's take. Suppose there is a swimming pool. There is a swimming pool. Okay, there is a swimming pool. Here, some water there. Okay, now there is a point A. Someone asks you to find what is the depth of this swimming pool. What is the depth of this swimming pool? Now tell me, if I join this point with this point, then does this distance is the actual depth? No, it is not the actual depth. Suppose someone join this point with this point, then is this distance is the exact distance or exact depth of this pole? No, it is not the exact depth. Someone draw a line or join these 2 points, then does it the exact or equal depth of the pole? Yes, it is the actual depth of the pole, because it is the shortest distance between the point or between the top of the water level and the bottom of the water level. So this is the exact distance or actual depth. So in order to find the exact distance and actual depth, okay, the smallest distance is always considered. The smallest distance is always considered. And second thing is, See, suppose I have joined this 2 points and this is the line. Then how this two lines seems to be? Tell me how this two lines seems to be? It seems to be 90 degree or not? Similarly here, this is the depth, this is the bottom. How it seems to be? It is the 90 degree. Clear na? So the smallest distance is the exact distance and it makes 90 degree with the bottom, with the ground. Okay, so this is the ground, this is the point, then it makes how much degree? 90 degree. Understood? So the smallest distance is the exact distance, exact depth, and it makes 90 degree with the ground, with the bottom. Okay, so here it is given P is equidistant from M and from L. Okay, so we have to draw the smallest distance, and we know the smallest distance always make 90 degree with the bottom. Since we draw the line from P to this line, so this must be 90 degree. This is clear? Similarly, this distance, this is the smallest distance, understood? From the point P to the line L. That means it also makes 90 degree. Are you clear? That's why I have given you two examples so that you can easily understand the exact distance, and the smallest distance is known as the exact distance, which makes 90 degree with the bottom, with the ground. Now, what we have to prove? We have to prove so that AP, so join AP, bisect the angle between them. Okay, so see, if we have drawn two lines, then what is the angle between them? This is the angle between them, yes or no? And we have taken here P as a point. Clear? And it is the equal distance to equal distance. Equal distance means suppose this point is your M, this point is N. Since it is given that this distance is equal to this distance, it is given. Now you have to find that AP bisect which one? Which angle? This angle. Angle between them means this bisect this angle. We have to prove that this angle is equal to this angle. Angle bisector means what? This angle is equal to this angle. We have to prove that. Okay. So let us prove it. What is given here? Here given PM is equal to PN because equidistance. Yes or no? Yes. And PM is perpendicular on line M. PM is perpendicular on line M. PN is perpendicular on line L. Okay. To prove AP is angle bisector of which angle? Angle A. Now proof. Okay, see. In order to prove that this is the angle bisector of angle A, we have to compare these two triangles. Which triangle? AMP, ANP. Okay. So between triangle AMP and triangle ANP, what are the conditions here? In triangle AMP, this side is equal to this side. Clear? This angle is how much? 90 degree for the triangle AMP. Now this angle is how much? 90 degree for the triangle AMP. So let us first take this angle is 90 degree, this angle also 90 degree. So this angle is equal to this angle. AMP is equal to ANP is equal to 90 degree. Okay, it is given. So it stands for right angle. Second condition is, see, if we consider this as a triangle, then this one is the 90 degree, and I have told you the front side, the opposite side of 90 degree is known as hypotenuse. So AP is the hypotenuse for the triangle AMP. AP is the hypotenuse. Similarly, for the triangle AMP, this is 90 degrees, so its front or opposite side is AP. So AP is also the hypotenuse for the triangle AMP. So AP is equal to AP because they are common side. This stands for hypotenuse. Third condition is that since it is given that P is equidistant from M, P is equidistant from N. So this distance PM is equal to PM. PM is equal to PM. It is given. So this stands for side. So by RHS congruency, hence by RHS congruency, what we can write? This triangle AMP is congruent to the triangle AMP. Do you understand it? So by right angle, hypotenuse and side, both the triangle are become congruent now. This is clear. But what we have to prove? We have to prove AP is the angle bisector. We don't need this. We need this. Now how can you prove? Since these two triangles are congruent, then can we write that their corresponding angles must be equal according to the exam 7.2. So we can write for the triangle AMP, this is an angle, which angle? MAP. For the triangle AMP, this is also an angle, NAP. But we know this triangle is congruent to this triangle, so we can write that this angle must be equal to this angle by CT or exam 7.2. So we have found that this angle is equal to this angle. It means AP divides the total angle A into two equal halves. Okay? It means AP divides angle A into two equal halves. Or you can write AP is the angle bisector. AP is the angle bisector. And now it is proved. Understood?